Hello, everybody. Thank you for joining. I'm Manish Pandey. I'm one of the maintainers for TFA and mostly contributing into EL3 runtime services. So today I'll be going into some of the topics which we have worked in last couple of years. And one of the major reason for a lot of refactoring is in introduction of ARM CCA, the 4-wall system. I have few topics going into order of more important to less important. And we'll try to cover as many as I can. But if we miss some of them, we can discuss later. But they are part of the presentation anyways. So on context management, BL31's main responsibility is one of the responsibilities to provide CPU context initialization and the vault switching routines. So the original design was based on 2-wall systems where there was secure and non-secure. But with, as I said earlier, with CCA introduction, we have 2 more vaults, realm and root. And EL3 is no more a secure vault component, but it has got its own vault, which is root. So why did we need refactoring? We need refactoring for first, to scale for 4-wall system, and secondly, to make EL3 to have its own context for its own execution. So we created basic design principles, and the details is already in the link. It's part of TFA Read the Docs. The first one is to reduce the EL3 firmware complexity and its footprint. So this is one of the design basic principles to reduce the EL3 firmware code size. The next one is EL3 should initialize the immediate used lower EL. So these design principles are, maybe I can clarify. I haven't written it there, but this is for 4-wall system. Or I have a, yes. So EL3 should initialize the immediate used lower EL, meaning it has to initialize EL2, secure EL2, realm EL2, or non-secure EL2. The third point is similar to the second one. It's a decentralized model. The dispatchers inside EL3 code called SPM dispatcher, SPMD, and RMM dispatcher, RMMDD. And for non-secure, you have PSEI library, which does the dispatcher role. And EL1 system registers should be saved and restored by EL2 managers, which are running at secure EL2, realm EL2, or non-secure EL2. And finally, currently we allocate the context memory blindly. We take the maximum number of features, allocate memory for each vault. Considering the EL3 firmware has limited number of memory, we should not allocate a memory for, say, a feature which is not used in secure vault. Don't allocate memory for that. So this is on the right-hand side. So this is all part of EL3 firmware. This is context management library, the core, and there are the dispatchers for individual vaults. So major changes which are already into the master is a lot of code has now been migrated from assembly to C, especially on the context management side. Context memory based on feature, it is done. Restricting few EL3 register to have per vault instead of per CPU copy. So as the number of, currently the design of context memory is, we allocate, for a given register, we allocate number of vault multiplied by number of cores memory for each feature register. So few of the registers which are going to be common across all the cores for a given vault. So we have reduced it, so saving some memory there. There is introduction of root context, which is ongoing. It's not merged yet. And finally, there is a utility to report context memory uses. So it's very handy to figure out what's the context memory uses. On exception handling, this is not changing the core of exception handling, but because this change was done in all the entry paths of EL3, And this was basically to catch a very rare scenarios where when we are, mostly for the system errors. So say the example, the scenario is, we have a system error in system, we are executing in lower EL, and which is not, the signal, the error is not signaled to P yet, and you make SMC call from lower EL. You come to EL3, what used to happen is, there is a pending error, it is not signaled, come to EL3, EA are unmasked at that moment, and once you go unmask the external aborts, it will trigger as a EL3 exception. And the purpose of this work was to identify and isolate any errors at EL3 boundary. So, so once we detect the error, we decide what to do based on the routing model of external aborts. So there comes firmware first and kernel first handling. So say you have made an SMC call, you came to EL3, and you found an error. What do you do? For firmware first handling, we will handle the exception, the generated exception which was caught because of synchronization first, because firmware is anyways going to handle the error. And once it is done, you then go and continue with the original exception, like SMC call. In kernel first handling, we reflect the error back to the lower EL, and we go into lower EL in such a way that you again replay the SMC call which was made earlier. And FitRAS, it's very related with FitRAS. So we have a documentation on TFA about firmware first and kernel first. Most of the things are there. So one of the changes we did was avoid using ESB instruction. The problem with the ESB is it consumes the error as well, apart from synchronizing. So we got rid of ESB instruction in TFA, and we now rely on fit IESB, which is implicit error synchronization. And we assume that if fit RAS is present, IESB is also present in TFA. It's a nice diagram, but I won't go through details. It's there in TFA documentation. It's very similar to what I explained in more detail. The third one is undefined injection. This is very recent, maybe last few months ago. This came from one of the use cases from partner. And this is not a proper solution. This is a safety net to catch the scenarios. So there is a disconnect between lower ELs in EL3 firmware. Lower EL, EL2 and EL1, they generally use ID registers to figure out the capabilities of PE, while EL3 is mostly statically enables it, all the features. And the chances of, in a given product or project, the chances of EL3 firmware being very old and hypervisor or OS kernel is very recent. So, so for a given ARC feature, generally the enable or trap is some EL3 register, which is reserved 0 in past, and in future you just introduce a new feature with that EL3 bit. Old EL3 firmware, which is unaware of this feature, will just write it to 0, which is different semantics, but still it's 0. And if lower EL accesses a system register at that point, it will trap into EL3, and most of the time it will end up in EL3 panic. The main problem is a VM can cause EL3 panic, meaning it can just shut down the system because EL3 is no more usable. So undefined injection was a type of safety net mechanism to inject this error back to lower EL, the EL which is capable of handling that exception, or is supposed to be handling that exception. And this could give some hint to the hypervisor or the OS kernel to maybe not using the feature in future or update the firmware. So that's the flow here on the right-hand side. The bit for FGT feature is disabled. Lower EL trying to access it because it sees the feature is enabled. There's an exception to EL3. And then here you figure out. So the solution is to figure out SPSR, recreating the SPSR. We have a fixed value of syndrome register for exception, and you figure out ELR, inject to EL2 or EL1, depending on whether ELP is running in host mode or not. Any questions? Firmware handoff. So this has got a bit of history. So it started maybe 3 years ago in one of the TFA Tech Forum meetings to standardize data passing between different boot stages. So over the time, the bootloader is not a single entity anymore. It's various phases. Just in TFA, we have BL1, BL2, BL31, BL33, and then comes the hypervisor and OS. So this is only focused for firmware interfaces, not touching OS kernel. This is standard way to standardizing the data structures and register uses between boot stages. It is meant to be universal, architectural agnostics, and lightweight data structures. Lightweight is important because over the time in firmwares, we started using device tree as a type of configuration file just for passing maybe 8 bytes of data. You are using device tree, adding some random entry into it. Because there is a device tree, firmware has to have FDT library, which increases the code size. So if you're just passing few bytes of data, better use a standard data structure rather than some newly built custom like config file. One of the examples is device tree. So this firmware handoff introduces a concept of transfer list, which is comprised of various transfer entries, and it propagates information during boot phases. Each T represents information produced by one of the prior boot stage and to be consumed by later on. And any stage can add, delete, or append a transfer entry. So the specification is at 0.9 currently, and we are planning to make it official 1.0 stable very soon. And initial support in TFA for all the 3 interfaces is done. There are patches in Opti as well as in U-boot. Raymond from Linaro is helping on in posting the patches for Opti and U-boot. And finally, I would like to highlight is it's very similar to U-boot's existing blob list, and just there are a couple of patches to update it to make fully compatible with blob list. So they are just a table highlighting what kind of T's are there. So FDT is one type, HOB, ACPI. There can be one transfer entry in the list. And there is a range for non-standard transfer entries. And also you have project-specific transfer entry. For example, all the projects related with trusted firmware, they can have one range. So we have few, in the current spec, we have few from this range, and these are already there, the standard ones. Now the question is, from ARM's point of view, we have done FVP, and we are planning to migrate other platforms, other reference platform to use it. But we want to have a wider adoption of this. And finally, we recently created a tool, host tool, to create a transfer list from given transfer entries. Because this is a very small library, but currently it is kept in all TFA, Opti, U-boot, everybody has got one copy of it. So making it a standard library would be good option, and maybe hosting it in trustedfirmware.org. Matteo?
See why not?
Yeah, okay. This is the next, yeah.
I have a question in connection to firmware handoff and dealing if you have a secure EL2. It means what should be the life cycle and what should be the memory which should be used. It means you should be having at the same handoff file, the same structure, just to be passing to every partition, or you want to create a copies, and then you want to, because this is also between the secure and non-secure, and there is a description for making a copy from the secure memory, because that's where you are creating the handoff structures, right? That before you hand it off to the non-secure, you are just doing a copy. But what's the situation for the handing in the secure world? It means it's already in the secure memory and you have a multiple partitions, right? What should be the life cycle for that? It means you are going to create a copy for every partition, or you are just going to share the same one across all of them? What should be the right way to go with?
So we haven't covered the SPM to secure partitions interface yet, because it overlaps with FFA boot protocol, and the story is not yet clear. What should we follow? Should we follow firmware handoff there in the SPM SP interface, or we can enhance this for with the firmware handoff? Is it?
Yeah, I'm just curious.
No,
right?
it's not. It's not solved yet.
I think we need to talk to the FFA spec maintainers and see whether they're willing to sort of adopt this to replace the FFA boot protocol. Fortunately, they got there first, and that was already ready for maturation before this was, because we had to do a lot more community sort of engagement to get buy-in for this. But hopefully, in the long term, it would be nice to use the same mechanism. But they're effectively doing the same thing.
Yep. Next topic is vendor-specific EL3 monitors or SMC calls. So this has been coming for quite a long time on mailing list to have something specific to TFA project. All the platforms can use it. The problem was, for a similar feature early on, if different platforms want to use a service, they have to redo same thing, maybe in OEM range or SIP range, and it causes a lot of duplicity and fragmentation. I would not call fragmentation, but duplicity. So this came into spec in 1.5 of SMCC, and it gives EL3 firmware to standardize the range for itself or IDs for itself, and also document the to avoid any collision in future. And it is recommended to use by tightly integrated softwares. It's not intended for general purpose software, because the same general purpose software can be running with different EL3 firmwares, and the chances of it being not working correctly is high. TFA has recently created this range for its users. So we identified a couple of existing services which we thought are good candidate for this range. So one of these is debugfs, and the other one was performance measurement. This used to be in ARM SIP range, and if people a different platform wanted to use this service or these features, they had to just copy paste all the code into their own zip range. The other use cases, this is from some of the requests in mailing list over the years, was Secure was trying to get memory map from BL31, or for debugging features, maybe try to have intentional panic in EL3 for some automation in test. Now, last year, Andre from kernel team, he came up with this idea of having, it's very similar to the ID, the lower EL's way of getting the feature capability of PE. So far we had static enablement of a feature, either it is disabled or enabled, but then came the third state, which is check. So disabled is disabled at compile time, always is always enabled, and check is, it will be compiled, but at every runtime access, it will be checked for the feature presence. And this, so disable and always is always ideal for a fixed CPU platform, but platforms like FVP, which has multiple configuration with different CPUs, is preferable to, or multiple configuration with different architecture features enabled, it's better to use check. And along with that, we also introduce a new feature detection debug feature where you can, at a development time, you can use this to see any disparity into hardware capability and firmware enablement. And for case where CPU does not have a feature and firmware has enabled it, it will simply panic early on. And finally, I think this is the last one. We also recently introduced ARC ARM measure minor macros to enable the architecture features. So earlier it had dual purpose. One was to enable the architecture feature, and it also used to get the MARC version for compiler. And because of this dependency, we can't upgrade our ARC features because the compiler support is not available yet. So the solution was to fix this by decoupling ARM ARC measure minor and MARC directive. And finally, this is good for platform owners now, that if you set a correct major and minor version in your platform make file, all the mandatory features will get enabled by default. You don't need to go and enable feature by feature directly in your make files. But we still, when platform still can override mandatory features, but it is discouraged. You should use or define major minor in the make file of the platform. Is it the last one? Yep. That's the last one. Thank you. Any questions?
I have one question.
Yeah,
one
go
more. What we are seeing over years on the platform which is size constrained, that pretty much just the firmware over and over is just growing. Are you doing something against that? Because pretty much what it is happening is we have a limited amount of memory, right? We are not doing pretty much any code changes in our platform. But because we want to be up to date, we want to take the latest security fixes pretty much, that we see that the code size is just increasing. It means we pretty much reaching, I would say every second year, that we need to look at our code and try to optimize that. It means because it's just growing, right? It's growing out. And this is something what we see that is going to happen next year again. It means, are you checking that pretty much the code which is going to the generic locations are not growing too much, or it should be pretty much the same?
I mean, we are also struggling with this problem for the last many years. And we had a very easy solution, convincing our modeling team to increase the SRAM size in FVP models. But this is one of the initiatives to reduce the size, the context management. I mean, the context allocation of memory it takes huge amount of memory. And the last point here, picking and choosing features to be saved and restored. So you are saving a lot of memory there. Go.
So I guess when you say memory, do you mean DRAM, memory at runtime, or do you mean flash, nor whatever the firmware is stored in? Because I'm assuming you care more about the latter than the former.
Yeah, or the DRAM.
Oh, you care more about the DRAM? Okay.
Yeah. I mean, both is increasing, yeah, you're right. But yeah, and the other point is, even this feature, per world copy instead of per CPU had saved memory. And the reason why we introduced this utility was to solve exactly the same problem you are facing. So we are also struggling, and you get new feature, you have to sacrifice.
Yeah, I was just going to say, I mean, it's probably more SRAM than DRAM, I guess, is the problem. On-chip static RAM, yeah, because that's costly. It should be as much DRAM as you want, but TFA tends, usually we recommend to run on on-chip RAM. But with when you get to V8.4 onwards and Secure EL2 becomes mandatory, or well, not mandatory, but if you enable this feature, this context management framework, the size of EL3 will sort of drop down because a lot of functionality is delegated to those EL2 entities, which can run in DRAM instead, and so the pressure on the SRAM should be reduced.
It's not a problem for...
I'm saying it's not going to grow forever. Obviously, you may not be there yet, but so there is a future plan. Basically, use Secure EL2 or RME, or both.
Any other questions? Thank you. Thank you all for attending.